So this starts back with problem number 10. So it says given a cube with sides 8. So I went ahead and put a cube picture on here so you could see it. Turn this down a little bit. So here I have sides of 8. Okay, so the first thing I need to do is find the this diagonal right here. Okay, it's asking you for the diagonal of the cube. So I'm going to find the front diagonal of this front face. Okay, so I know that if these sides are 8, this face is going to be 8 square root of 2. Okay, so this is 8 square root of 2 by Pythagorean theorem or our special right triangle rules. Okay, so what I'm trying to find here is this diagonal that goes, let me see if I can draw it well here, is this diagonal inside. Okay, so when I'm trying to find that line, let me change the color so it's a little bit easier to tell. That blue dashed line there, what I get is a right triangle right here. Okay, so this is now a right triangle. So I know that this side that I just found is 8 square root of 2, and I know that this side right here is 8. So now I can do Pythagorean theorem to find c squared. So in essence, what I have, let me see if I can draw it here for you, is a right triangle. I know this doesn't look good, but a right triangle where this is 8 square root of 2, and this side is 8. So I'm going to do 8 square root of 2 squared. Okay, so if you're not doing this in your head and you're trying to use your calculator, you need to use parentheses. Oops. All right. So squared plus 8 squared, and then I'm going to take the square root of that to find my length of my diagonal. Okay, and when you do that, you end up getting 8 square root of 3, or if you did it using Pythagorean theorem, you would have gotten a decimal, and that's okay. Okay, so this is 8 square root of 3 if you did it in your calculator without reducing the radicals. Okay, number 11 says if the diagonal of a rectangle is 20 square root of 3, so here's my diagonal, and that is 20 square root of 3. And it forms a 60-degree angle with the length. So here's the length on the bottom. So this is a 60-degree angle. Okay, so yes, it's a right angle here. So this is our 30-degree angle. Okay, so what is the width of the rectangle? So I can do my little special right triangle table, if that's how you do it. Square root of 3, and then 2x. So the 90-degree, side across from the 90-degree angle is 20 square root of 3. So that means 2x equals 20 square root of 3. So I can divide both sides by 2, and that gives me that the 30-degree side is 10 square root of 3. Well, that's the length. So the width is 10 square root of 3 times square root of 3, which gives me 10 times 3, which is 30. Okay, so my width is 30. All right. Okay, so it says a person views a bird from the top of a pole. Okay, so here's my pole, and person is standing 50 feet from the base of the pole. Okay, so here's my person is standing right here. So this is 50. Tell me it's 50 feet from the base. Okay. All right. From the base is looking at a 60-degree angle of elevation. Okay, so person's looking up, and that forms a 60-degree angle right here. Okay, what is the height of the pole? So that's what I'm trying to find, is this. Okay, you could do this a couple ways. You could use your special right triangles, which is what I'm going to do. You could also use trig, but since this is a side across from the 30, that means that this side across from the 60 is going to be 50 square root of 3. The angle of elevation from a boat to the top of a lighthouse. So here's my lighthouse, and my boat is somewhere over here. So let's see. So the angle of elevation is 25 degrees. Okay, so this is 25 degrees. The angle of elevation to the top of a 75-foot lighthouse. So this is 75 feet. What is the distance from the boat to the lighthouse? So this is the side you're trying to find. Now, since our angle is 25 degrees, we can't use special right triangles, so we're going to use trig. So here, if I'm looking at this angle, I have the opposite side and the adjacent side. So that would be tangent. So tangent, oops, can't write, tangent of the angle 25 equals opposite, so 75 over x. Okay, so if I'm solving for x, I cross multiply and I get x and divide, and I get x equals, acted up here, 75 divided by tangent of 25. Okay, so in your calculator, make sure it's in degrees mode and type that in, and you should get 160.8. So 160.8 feet away. Okay. All right, a person on a bridge sights a boat at an angle of depression of 23 degrees. Okay. So our person is up here. I'm just going to draw it like this, and sees a boat down here. Okay, so they're on a bridge and they look down and see a boat. Okay, so the angle of depression is 23 degrees, so this is 23. Okay, and I like to redraw my triangle this way by using my parallel lines. I know that this angle is 23. Okay, the height of the bridge is 36 centimeters, so that means this is 36. Find the distance of the boat from the bridge. Okay, so I'm looking for this side. So again, I have opposite over adjacent, so I have tangent of 23 equals 36 over x. So cross multiply and divide, and I get x equals 36 divided by tangent of 23. Plug that in your calculator, and you should get 84.8. Okay. A person stands 500 feet away from a monument. The distance of his line of sight. Oops. Okay. So he's 500 feet away from the monument. His line of sight, so here he's standing here, this is his line of sight, is 3480. Okay, so this is 3480. Find the angle of elevation, so this is what I'm looking for, to the top of the building. Okay, so now I have the hypotenuse and I have the adjacent side. So the trig function with adjacent side and hypotenuse is cosine. So I have cosine of x equals 500 over, sorry, my pen's acting up here again, 500 over 3480. Okay, so when you put this in your calculator, remember you have to do the inverse cosine function. So I'm going to do second cosine and then 500 divided by 3480. Okay, and normally we round to the nearest degree, so it's 82 degrees. All right, 15 a flagpole casts a shadow of 36 feet. So here's my flagpole, here's my shadow. So the shadow is 36 feet. How tall is the flagpole if the angle of depression of the sun, okay, so my angle of depression of the sun is 15 degrees. And again, I can rewrite that down here because they are the same angle. So I have opposite over adjacent. So I can say tangent T of 15 degrees equals x over 36. So in order to solve for x, I do 36 times the tangent of 15, and that should give you about 9.6 feet. 17, an observer from the top of a 60-meter building. So here's my 60-meter building. Sights two cars, one behind the other. The angle, so, okay. So here, let's put a little, this will be my one car and then another car, let's say. Okay. The angles of depression to the cars are 36 degrees and 25 degrees. Okay, so from here to here, I'm going to say that this one is 36 degrees. And from here to here is 25 degrees. Okay. What is the distance between the cars? Okay, so I'm really looking for this distance right here. So the way I'm going to do that is I'm going to do two trig ratios. So the first thing I'm going to do is find what this distance is, and then I'm going to find what this distance is, the whole distance, and then subtract them. So I have, okay, I'm going to call this y, I'm going to call this x, and I'm going to call the whole thing z. Okay, so on this one I'm finding opposite over adjacent, so I'm going to do tangent of 36 equals 60 over y. So to solve that, I'm going to do y equals 60 divided by tangent of 36, and that gives you y is about 82.6. Okay, so now I can find x, I can find z, the whole thing, because this isn't a right triangle right here. So I can find this whole length by doing the tangent of 25 equals 60 over the whole piece. Okay, so let's go down here and do that. So I'm going to say tangent of 25 equals 60 over z, which is the whole length. Okay, so z is equal to 60 divided by tangent of 25, which gives me 128.7. Okay, so now what I know is this whole distance is 128.7. So that's the distance from the building to that car. Okay, and I know that this piece is 82.6. So the difference between the cars has to be the difference of them. So I take 128.7 minus 82.6, and that gives me 46.1. So my answer is 46.1 meters. Meters, yeah. Okay. 18. A plane is flying at an altitude of 3,500 meters So that's 3,500. The angle of depression from the plane to a control tower is 35 degrees. Okay, so hopefully you get it by now. I'm just going to go ahead and put that down here. Oops. Okay, so this is 35. What is the air distance? So this is the air distance, okay, from the control tower to the plane. So here's your control tower to the plane. So I'm going to say tangent of 15. Oops, sorry. Sine. This is, I was looking at the wrong problem. Hypotenuse and opposite. So sine. So sine of 35 equals 3,500 over x. So cross multiply and divide, I get x equals 3,500 divided by sine of 35, and I get 610, oops, 6,102.1. Okay. 19. A 9-meter ladder is placed against a building. Here's my building. Here's my ladder. The ladder is going to be at an angle of 50 degrees with the building. Okay, so it's this angle. Okay, so be careful there. It's with the building. All right. How high is the ladder placed on the building? Okay, so this is 9 meters. This is my ladder length. How high is the ladder placed on the building? So that's x. So this is the adjacent hypotenuse, so that's cosine. So cosine of 50 equals x over 9. So x equals 9 times the cosine of 50, and I get 5.8 meters. Okay, 20, 21, and 22. If a parallelogram has two consecutive congruent sides, then it is a rhombus. Well, if you think about a parallelogram, if it has two consecutive congruent sides, so if these are congruent, and it's definitely a parallelogram, then these have to be congruent. So yes, it is a rhombus. Okay, if you have a parallelogram that has congruent diagonals, that's one of the properties that we learned. If it has congruent diagonals, then yes, it is a rectangle. If a quadrilateral has two pairs of sides congruent, then it is a parallelogram. Well, that's true. If I have a quadrilateral, so 4 sides, no matter how I draw it, if these has two pairs of sides congruent, so these pairs and these pairs, then yes, then it is not necessarily a parallelogram. We don't have enough information to prove that, so that one is false. Okay? So if it has two pairs of sides congruent, then it is not necessarily a parallelogram. Okay, it could be another figure, all right? Okay, 23. We have a rectangle, RSTU, so let's label this figure RSTU. RS is 4x minus 6. Sorry, it's not working right today. Okay, and UT is 2x plus 20. And ST is 2y minus 3. And RU is 3y squared minus 11y minus 13. So I know on a rectangle that opposite sides are congruent. So I can say 4x minus 6 okay, so 4x minus 6 equals 2x plus 20. Subtract 2x from both sides, and I get, hold on. Okay, so I get 2x, and then add 6 to both sides, and I get 2x equals 26. So x is 13. Okay, but it's asking for what side UT is, so I go back and plug that in. 2 times 13 plus 20 gives me that UT is 46. Okay, so UT equals 46. All right, and then I need to solve for y. So I get 3y squared minus 11y minus 13 equals 2y minus 3. So subtract 2y, and I get 3y squared minus 13y minus 10 equals 0. Okay, and then you can factor using whatever method you're comfortable with. I'm going to use the slide and divide, so slide my 3 to the end, and I get y squared minus 13y minus 30 equals 0. My factors of 30 that add up to give me negative 13 are y minus 15 and y plus 2. And then I have to remember to go back and divide by that 3. So I get 3y minus 5 and, oops, I'm sorry. Sorry, that's not right. Forgot to reduce first. Okay, so sorry about that. So 15 divided by 3 is 5, so I get y minus 5. And then this doesn't reduce anymore, so I get 3y plus 2. So my answers are y equals 5 when you solve that, and y equals negative 2/3. And some of you can realize that all you have to do is take this, reduce it, take this, reduce it, and change the signs. So my answer I'm going to use here then is going to be y equals 5, because when I plug in the negative 2/3, that's going to give me a negative answer. So when I go back and plug in 5, 2 times 5 is 10, minus 3 gives me 7, so ST is 7. Okay? All right. 24, given parallelogram ABCD, so I'm going to label it ABCD, with measure of angle A is 115. Measure of angle B is 5x. Measure of angle C is 6y minus 5. Find x and y. So I know that angles across from each other, opposite angles, are congruent in a parallelogram. So I can say 6y minus 5 equals 115, so 6y equals 120. So y is equal to 20. Okay, and then I also know that angles, consecutive angles are supplementary. So I can say 115 plus 5x, or 115, and then I could have plugged in the y here to figure out what this was, but I'm going to say 115 plus 5x, because they want me to solve for x, is equal to 180. So subtract the 115 and I get 5x equals 65. So x is equal to 13. Okay, 25. They gave us a picture. They told us that JL is 3x minus 14 and MO is 26. Well, I know in a rectangle that diagonals are congruent, so that means that 3x minus 14 has to equal double 26. So 3x minus 14 equals 52. Because if just this piece is 26, that means the whole thing is 52. So 3x, so I can solve that by adding 14 to both sides and then dividing by 3, and that gives me that x is 22. And that's what they wanted, so x is 22. Okay, measure of PQR, so this whole thing is 130, so that makes each piece 65, because in a rhombus, the angles are split evenly, remember? And then I also know that this is 65. Cuts those angles in half, bisects. So then I can say that 180 minus 130 leaves me with 50, so this is 25, because remember the angles are supplementary. So if this is 130, this has to be 50. So each one is 25. Okay, so then over here, I also know that angles in the center, these are perpendicular. The diagonals create perpendicular bisectors. So this is 90, QPS is 50 degrees, this is 65 degrees, and QRP is 25 degrees. Okay, all right. This tells me that JK is congruent to KL, and this is congruent to this, and then on this side, these are all congruent. Okay, and if this is 22, then I know that this is 44, and this has to be 66, 3 times as big as this one. Okay, so KO is 44, JP is 66. All right, XY is 10, XQ is 6. So if this is 6, then that means this piece is 4. If this whole piece is 10, that's a radius. Well, then I know that this XA, this segment, is also 10. So by Pythagorean theorem, I know that AQ is 8. So AB is 16. Okay, if the measure of arc CA is 80, so this is 80 degrees, and then B is 30, find the measure of arc CD. All right, so I'm going to call this X. Okay, well, if I'm trying to find this piece, I know this piece is 360 minus this minus this. So 360 minus 80 is 280. So this piece that's left out here, this arc, is 280 minus X. So by the theorems we learned, we know that this is 280 minus X, this arc minus this arc, so minus X divided by 2 equals 30. So 280 minus 2x equals 60. Subtract 280, divide by -2, and I get 110. That's what x is, and that's what I was looking for, the measure of arc CD. Okay, find the circumference of the circle. So here I have a square that has sides of 12. Okay, well, I need to find this diagonal, pretend that goes through the center, which would be 12 square root of 2 by using my special right triangles. So the circumference would be pi times 12 square root of 2, pi times the diameter. So I can just leave it like that, 12 square root of 2 pi. Okay, if you want to work it out using decimals, that's fine too. All right, find the area of the shaded region. So the first thing I'm going to have to do is find the area of the circle and the area of the square and then subtract them. So I'm going to first of all, I know that the length of the side of the square is 10 square root of 10. Okay, right? Because if this is halfway, then this whole side is 10 square root of 10. And this side is 10 square root of 10. So the area of my square is 10 square root of 10 times 10 square root of 10, or 10 square root of 10 squared. So I get 100 times 10, right, which is 1,000. All right, so now I need to find my area of my circle. Okay, and you could have done this a couple different ways. I didn't really use, well, I found the diagonal. So if I know, because I need the diagonal for the diameter, so I need 10, if this is 10 square root of 10, then I know that this is 10 square root of 10 times square root of 2. So that makes 10 square root of 20, okay, which is also the same thing as my diameter of my circle, okay? So that means that my radius is half of that, which would be 5 square root of 20. Okay, so now the area of my circle is pi times r squared. Okay, so when you multiply that out, you get 500 pi. So I can leave this either in terms of pi or go ahead and use decimals. So if you leave it in terms of pi, I get, so in terms of pi, I get 500 pi minus the area of my rectangle, which was 1,000. So I can leave it like that, or you can plug it in your calculator and you get about 570.8. So either way is fine. Okay. 32, find the length of an arc of a circle with a radius of 6 and a central angle of 81. So this central angle means that I can take, to find the length of the arc, I use the measure out of the angle out of 360 times length is pi r squared. That's area times the circumference, which is 2 pi r. So 2 pi times 6. So when you multiply that out in your calculator, and I left it in terms of pi, you get 2.7 pi, or about 8.5. Okay. This one, find the area of a sector with a central angle of 63. So I'm going to do 63 over 360 times pi r squared. Okay, multiply that out, and I get 567 over 40 pi, or since that one's not a very nice fraction, you could go ahead and change the fraction to a decimal and leave it as that, or you can leave it as a decimal completely, which is 44.5. So any of those answers are okay. Okay, 35. Given circle A with tangents BD and CD, find the measure, and the measure of BDA is 40. So BDA is 40, so right here, 40 degrees. Find the measure of BABD. Well, they told me this is tangent, so that's 90. So this one is 90 degrees, so that one was easy. And then BAC. Well, in order to find this whole angle right here, pretending those lines are straight, I can do 180 minus 90 minus 40, or just 90 minus 40, which gives me 50, and then this has to be the same. So this would be 100 degrees. Okay, this one you're using the same circle, so on your paper it's not redrawn for you. AB is 10. Okay, so let's go ahead and draw our line. Oops, let me draw a better line. Okay, so this is 10. BD is 24. Find AD. Well, this is a right angle, so I can do Pythagorean theorem to find AD. So 24 squared minus 10 squared, take the square root, and you should get that AD is 26. Okay, find CD. Well, CD is going to be the same thing as BD, so that is 24. And then now I want you to find the length of BE. Well, if you note of arc BE, there is no E, so you need to add point E right here. Okay, so this is going to be point E. And then, that's poorly written. Okay, so there's E. And then they want you to assume you're using the same angles as this picture. They didn't tell you that, but that's what they're assuming. So if this angle is 50, still, and this angle is 50. Okay, so it wants you to find the measure of length BE. Well, BE, I would take that arc measure, which is going to be 100, because that central angle is 100 out of 360, times 2 pi r, and r is 10, because that's what AB is up there, or AC. Okay, so when you multiply that out, you get that is 25 over 9 pi. Okay. It's a 9, not an A, but you get the picture. Okay, in the area, you're going to do the same thing. Take 100. Okay, so you're going to take 100 out of 360 times pi r squared. And when you get that one, you should get 250 pi over 9. Okay? All right, and I'm going to stop there for now.